Preparing, recording. Good. All right, so this is the warm-up. And what we're looking at for this is just like a multiplication table. You multiply the entries on the sides and the top, and they multiply to give you the entry in the middle. So what do we get at this top left?
X squared.
All right, I'm going to ask for 2 each, so give me another box. X squared and what else?
3x for the top. Right?
Good. It's 3 times x. That meets where we're going to put our answer. It's just multiplication. So everything's multiplication today. Malaysia, what do you think? 3x and 9. Good. So you see how we do these boxes out, right? And we see here that it's equal to x plus 3 squared because the expressions that we use are always going to be on the outside. We basically factored x squared plus 6x plus 9 to be x plus 3 times x plus 3, x plus 3 squared. Malaysia. All right, let's do the other direction. Here, they give you the product of the two values multiplied. Here they have x squared, so what times what gives us x squared? Who wants to answer that? Yeah, x. X times x. All right, who can fill in the other two? Reese? Who can fill out the other two? We're seeing that we have x times x gives us x squared. Now watch this. X times what? X times what gives us negative 4x? Raise your hand. Get your Isabel. Negative 4. So I'm going to negative 4. How about then up here? Looks like it's going to be the same. Okay. And then the last one that I'll ask for this one is, whoop, that was later. What goes in this box down here? 16. You got it. So it's like a multiplication table. Now here's the deal. If you look here, all the things are in the box. Look at everything in the box. If we combine those like terms, we get x squared minus 8x. You guys agree? X squared minus 8x. Everything what I'm covering, or except what I'm covering. These three give us where we started, right? We have, from the original equation, added a 16. So my students from last year, if we add 16, what do we have to do out there to keep it exactly the same? We've just added something, then we have to subtract 16. That's it. Good. So if you weren't in my class last year, on Emoto I put a video on how to use algebra tiles. It allows people to think this in their head and do it in their head even, because it's spatially relating sizes of shapes. So look at that, check that out if you want to learn how to do it. So I'd rewrite this, right? Look what we have. X minus 4 squared, because there's two of the exact same things, right? X minus 4 squared, minus 16. I've converted and completed the square. And from there, I could graph that easily. I could do a lot of things. We won't have to graph it, but you've made it into the form that's helpful. Okay? That's kind of the goal for today, that and finding the inverse. So I'm going to pause it. And then, all right, here we go. So again, this week is just about inverses. So the function notation versus the inverse notation, we have to keep that in mind for the rest of the week. We're starting with the inverses of quadratics because that's what we did last year. We're not going to be getting into quadratics where we have to graph them again, find the zeros, minimum, maximum. We're not really doing that. We're mostly just using this as a way to practice these equations. And then at the end, we double check using the composition, which is just another math term for just double checking it. Because if we find that the inverse is a certain equation or expression, and we plug that into the original, substitute in for x in the original, it's all going to cancel to just equal x if we did it right. Okay? So what we're going to do first is, with the quadratic, we're going to do completing the square if needed. Okay? But I'll give you a hint. When you have one term, a monomial, like this, you're not going to be completing the square. We look at this right here, and the parent function of a quadratic is just x squared like that. If you remember what a quadratic looks like, it's a parabola, right? It's a parabola. So we would have x squared would be starting at the origin, and it would go up on either side. It'd be a little bit narrow, a little bit stretched vertically because it's a 4 out front. But those aren't details you really have to remember. You could, actually you won't need to remember that, because I'm not asking Math 3 to find the domain and range. But you would need the graph to find the domain and range from. So if I'm just filling this in for those watching with honors, I know the domain is talking about the x values. So the domain of my function, it goes up and out forever, right? It goes up and out forever. It goes up, but it's also going out. So the domain of this is negative infinity to positive infinity. The thing with the normal function and the inverse function, the domain and range switch. They switch. Okay, so if the domain is negative infinity to positive infinity for f of x, the inverse is going to have the range as negative infinity, positive infinity. Okay, it's not as much a detail for math 3, but it's still something to think about because the inverse switches everything. The inverse switches everything around. Okay. The range here is talking about the y aspect, so the y, it starts at 0 and it goes up forever. So the range is 0, positive infinity. If my range for the function is 0, positive infinity, what would my domain be? Yeah, it's just going to switch, right? It just switches. And I don't mind if that, for honors, is just a rote memorizing thing you do. What? Oh, no, but that's right. That's right. Yeah. Thanks for checking. All right. So if you have to complete the square, you do that. For the honors number 2, we find the vertex from the graph, and we find the domain and range. They switch for the inverse. But now we're getting to what we're going to do. Okay, this is the main thing for you guys today. To find the inverse, we switch the x and the y. It's in function notation, but I know my f of x is really my y variable. We've seen that before. So all I need to do here is, this is really my y value here. So I want to switch my x and my y. So watch, we're going to get to this point, 4y squared. Okay. So now that we have it in this form, all we have to do now is solve for our y, and then we're going to, at the end, just relabel it as our inverse. So we need to solve for y, and then we're going to relabel that as, when we solve for y, that y is the inverse of the expression. So this is maybe bringing back what we did last year, so think about it. I want to get to y. It's y squared. It's also times 4. Just like peeling an onion. Remember last year I was obsessed with drawing onions? Yeah. So I just went to Italy, so maybe I'm better with onions. No, it's still a pumpkin. Dang it. All right. So we're not peeling a pumpkin. It's peeling an onion from the outside in, right? You peel the outsides in. Okay, so I want to first, let's get rid of the 4. What am I going to do? Instead of multiply? Divide. Gone, gone. So now we have x over 4. X over 4 is equal to y squared. How am I going to solve for y then? Square root. We're doing opposite inverse operations. Good job. So I know that we have y is equal to x over 4. This is our inverse, but look, I might get confused because the original function was y is equal to 4x squared. So what are we going to do in order to remember that this one is our inverse? Yeah, the inverse function of x, we're going to have the square root of x over 4. This is our inverse. It's that easy to find for some of these. Some take more work. Example 2 takes a little more work, but it's good that we're starting with this. So I erase this onion pumpkin. And now what do we have to do? Okay? Okay. There's chairs here too.
Not like the glare.
Oh, the glare's getting you. Maybe a little bit closed. All right, we should get to see. Okay. So the thing is, the last bit, it's called composition. It's just basically taking this inverse, right? This inverse right here, and we're going to plug it into our original f of x. So watch what I'm going to do. I'm going to take f of root x over 4 is equal to 4, and then what am I going to put in for my x value since I'm doing the function of root x over 4? If this was the function of 2, I would substitute in 2. If it was f of 2, I'd substitute 2 in for my x. But what am I going to plug in for this? That part's a little bit weird. But just remember, once you find the inverse, you take that entire expression, you plug it back into the original to double check. If it all reduces to equal x, then we know that we have the correct inverse. Let's see. Oh, this isn't that. Sorry, this is this is all square rooted. Makes it easier. How about this? Square and square root, what's going to happen? What's going to happen? They're going to cancel each other out. Square and square root cancel. So then we have 4 times x over 4. What happens to the force? Cancel out. What do we end up with? X, check mark. We did it. Okay. You see that's going to kind of work? Where's the crux? Give me a candy crux. And I'll give you candy. The whole thing because of the glare. So the candy crux is sitting over there. Oh. How about on this side? Are we seeing what we're doing? We change x and y. We solve for the new y. That's our inverse. We take whatever that's equal to and we plug it in for x from the beginning to see if we have it. No? I feel like you get used to it after we get used to dealing with these equations again. Okay? Now listen.
So, like, the first step, is it 4y squared? Like, right there, like, where it says example 1, right there, that equation on the bottom.
That?
Yeah.
Yeah. That is 4y squared was equal to x. I divided by 4 on both sides to get rid of it over here.
If it was like 4y squared, now the bottom equation on the x squared. Do you like switch it around?
I was here. I want to solve for y, so I divide by 4. I divide by 4.
Yeah.
Then it's y squared is equal to x over 4. I square root both sides. Square root both sides. Maybe one y is looking like a 4 somewhere. Okay.
The thing is, I don't understand. It was f of x equals 4x squared. And the equation on the bottom is 4y squared. We're supposed to switch x to y.
Yeah, that's what we do.
Oh, okay.
That's the whole thing about the inverse. When you want to find the inverse, wherever the x is or the y is, you switch them in the exact position, and then you solve for your new y. Okay. So, a real easy one. If I had this, to find the inverse, I would switch. I would switch them, and then I need to know what the new y is, so I would divide by 3. Y is equal to x over 3. That's how I would get to that statement. Okay. So, I expect that at the beginning of class tomorrow, because we're getting back into this new kind of phase, we're going to go over all the problems if we need to with homework. But keep running out of time. I talked too much about Italy. A lot of kids from my other Math 3 were doing the testing today, so I kind of planned on tomorrow being a little bit more depth with this, just looking at another bit. Honestly, guys, I got to do this one really fast. I'm going to do it on fast forward for the honors folks. Okay, so we'll start with this problem tomorrow, but I just need to do it quick. Okay. So first bit, maybe you'll understand it if you see it all really fast and you're not writing. So still pay attention, please, with this. I know that I have x squared, and what I'm going to do in order to complete the square here, I want to take the 10x, divide it in half. That allows me to say 5x and 5x. If I combine all these terms, I get this, right? If I combine all the terms, I haven't changed anything yet. I know that this is x and x to get x squared. I know it's x and 5 and 5. So I have my two expressions I'm going to use, but now I need to multiply to get this one here. 5 times 5, 25. Because I added 25, I need to subtract 25. Okay? Thus, this f of x is equal to x plus 5 squared minus 25. All right? This is vertex form of the equation. This is more for the honors, but if we look at this, we know that from here, we know we have a vertex at -5, -25. Okay? Because this is a parabola, I also know that the domain continues to go from negative infinity to positive infinity. The range for the inverse is going to be the opposite, or the same, but in a different position. We're going to start here at the vertex of -25. It's going to go from -25 to positive infinity. We could graph that right here. We have a -5, -5, -25. So this is basically the graph of this. Okay. Looking at this, I know that the opposite is going to be it's going to be switched for my domain and range, or switching like so. Okay, I'm going to keep going. I'll do this problem again tomorrow for everyone here. Okay. So looking at this, now what we need to do is find the inverse. I know that this is my y is equal to. So instead, I'm going to change it. I move the 25 over. X plus 25 is equal to y plus 5 squared. I square root. Square root of x plus 25 is equal to y plus 5. I minus the 5 over. X plus 25 minus 5 is equal to y, which at that point I could change to my inverse. Okay. Here's my inverse. To double check with the composition, which I won't be able to get to, I would take this entire expression, which is complex, and I would re-input it into my original equation here. F of root x plus 25 minus 5. And that would be equal to, right here, I'd put it in for x, square it, I'd multiply it by 10, and I'd have to consolidate to get it back to where I wanted. So watch, x plus 25 minus 5 squared plus 10x plus 25 minus 5. You would then work these out. It would be kind of a mess. That would be something we'll look at tomorrow. I might do an easier example. But then you should, if you work this out, it should equal x after we've done this composition part. That's just double checking. Thanks for sticking. Thanks for listening to the Italy stories. At home, I'll add to this tomorrow.